Hello students, today we are going to discuss about the complex number and in mechanical PPT I am just using this image because I think so after completing of BTech mechanical engineering most of you will be working in the plant similar like this and it is just a small task for you. If any one of you can guess which plant is this or what is the production of this plant. A complex number is introduced to satisfy the problem that exists in the equation, that is x square plus 1 is equal to 0, because there is no solution, there is no real number which satisfies this equation. For this problem x square is equal to minus 1 and x is equal to plus minus under root minus 1, which is a complex number. Introduce the complex number from this problem, and a complex number z is represented as a real part plus imaginary into a real number, where a and b are the real number and z is a complex number. And real part of the complex number can be represented as the real part of z, and imaginary part of the complex number is the imaginary part of z, where if we write imaginary part of z, that means imaginary part of z is equal to just a b without iota, because we are considering only the imaginary part which is multiplied by the iota. If a plus b iota and c plus d iota, if we say that these both number are equal if and only a is equal to c and b is equal to d. A complex number with real part as a minus 3 and imaginary part as a 0 is a real number. That means every complex number is having a real number involved in it if the imaginary part is 0. Every complex number z, in a previous page we just mentioned z is equal to a plus iota b, but over here we are mentioning as a z is equal to x plus iota y is actually a same representation, where we said that a and b are the real number. Over here the similar term we are saying that x and y is the element of real number, set of real number. A complex conjugate of a complex number is represented as a z bar. Z bar is equal to x plus iota y, where the imaginary top part is replaced by the sign, changed by the sign. Mod of z square is equal to z into z bar, which is equal to x square plus y square. For adding the complex number a plus b iota plus c plus d iota, we just add a real part with real part and the imaginary part with imaginary part, so that a plus c plus b plus d into iota, where this is the real part and this is the imaginary part. Again, subtracting a complex number from one number to another number, we just subtract a with c. That means a minus c is the real part plus b minus d. B minus d is the imaginary part. The resultant is this. If we multiply a complex number a plus b iota into c plus d iota, then we have to multiply a with the complete number, that is ac plus ad iota, and b is multiplied, b iota will be multiplied with the complete number, this a plus bd, that is bc iota bd iota square, and this bd iota square will be replaced by minus of bd, because iota square is equal to minus 1. So ac minus bd is the real part and ad plus bc is the imaginary part. Now if we are going to divide a number a plus b iota with c plus d iota, where remember c is not equal to 0 as well as d is not equal to 0, if both are 0, then a number divided by 0 will be undefined number. So it is a condition for dividing a complex number with a complex number that denominator should not be equal to a 0. Then multiplying rationalizing this term, then we take a negative conjugate of c plus d iota, that is c minus d iota, multiplying the c minus d iota from numerator as well as denominator. We get the numerator as this and denominator as this. Now iota square is replaced by minus 1, so finally the denominator is c square plus d square, and separating the real part, this is the real part of the number and this is the imaginary part of the divided number. Absolute value or modulus of complex number. If the complex number is a plus b iota, then modulus of a plus b iota is equal to under root of a square plus b square. If z1, z2, z3 and till zm are a complex number, then the following property should be hold, that is modulus of z1 into z2 is equal to mod of z1 into mod of z2. Dividing a z1 by z2 and the modulus is equal to dividing the z1 by z2 by the modulus, and the modulus of z1 plus z2 is less than equal to mod of z1 plus mod of z2. This is the less than sign. Again, modulus of z1 plus minus z2 is greater than equal to modulus of z1 minus z2. And distance between the two number, if z1 is a complex number as well as z2 is a complex number, then the difference between the point is modulus of z1 minus z2, that is equal to under root of real part of first number x1 minus x2 whole square plus imaginary part y1 minus y2 whole square. Now it is a graphical representation of the complex number. If z is equal to 3 plus iota 4, then this complex number is this point represented by this point. Suppose if we multiply z with iota, then we have 3 iota minus 4, that will be equal to, if this is the representation, vector representation of the first number z1, then z2 is equal to 3 iota minus 4. This will be represented as 4 in a real, minus 4 in a real axis, this minus 4, and 3 iota in the imaginary axis, that will be this. Then we have this point, this is the z2 and this will be considered as a z1. Again, if we multiply z3 is equal to iota into z2, then what we have, z3 is equal to, multiplying this term with iota, we have minus 4 iota minus 3 iota into iota, that is iota square is equal to minus 3. Then this point z3 is equal to minus 4 in imaginary axis, that will be over here, it is minus 4, and minus 3 is this point, this will be considered as this is the minus 3 minus 4 point. It is just a 180 degree from the z1, this is the z3. So we can say that if we multiply minus 1, if we multiply a complex number with minus 1, we will have 180 degree changes. That means if we multiply by iota square in a complex number, we will have 180 degree change in the vector. Let P be a point in the complex plane, then a complex plane z is equal to x plus iota y, or represented by the pair set x, y, and the polar form of z is equal to x plus iota y is equal to r cos iota sine theta, where r is equal to under root of x square plus y square, and x is equal to r cos theta, y is equal to r sine theta, where r is called the modulus or absolute value, and theta is equal to tan inverse y by x is the amplitude or argument of z. A theta is actually the angle that line OP marks the positive axis. That means if this is the axis and this is the point P, then this angle is theta. Thank you. For any doubt and any query, please feel free to contact me.